Welcome back to Introduction to Programming. This is video 8 in our series. My name is John Dwayne. Today we are going to talk about operators. This is a very straightforward topic, especially in Visual Basic for applications. I will go through the different types of operators, or actually the different types of operations, describe the operators that execute those operations, and then we'll have an example. I will also give you a taste of how the operators in other languages are mostly the same but different in a few key ways. First, the arithmetic operators. As you can see from this chart, these operators look similar to what you learned in grammar school math class, to a point. Addition and subtraction look familiar. Multiplication is a star. See it there. Division is a right-leaning slash. The exponent symbol is the upside down V. They will all work in code as you might expect, and you'll see that in the example. What is really different from grammar school math class is the left-leaning slash symbolizing integer division, and the mod operator for modulus division. Integer division gives you the result of a division operation as an integer. Thus, integer division with 5 divided by 2 equals just 2, not 2.5. The mod operator returns only the remainder in a division operation. Thus, 5 mod 2 equals 1, because 5 divided by 2 is really 2 with a remainder of 1, and modulus is just interested in the remainder, so the answer is 1. These unusual operators come in handy in lots of situations. For example, let's say you want to know if a number is odd or even. The best way to determine this is to use the mod operator. If the number in question is divided by mod 2 and the result is 0, the number is even. If the result is 1, the number is odd. Easy. So next are the comparison operators. Greater than, less than, equals, not equals, combining equals with greater than or less than. These are all pretty straightforward. You've seen those before. The same is true farther down in this chart of and or. These are used extensively with if-then-else statements to test for certain conditions. If you're curious about XOR and NOT, feel free to read about them. I don't use them in VBA, though that is really only a matter of my personal coding style, not because they're not useful operators. Okay, what about other programming languages? There's too many to show you everything, but I'll give you a sense of what the operators look like in the C family of languages. Arguably the biggest language grouping, taking into account C, C++, Java, Objective-C, and C#. So I have a chart for that. So this comes from Wikibooks. It's a pretty nice chart. As you can see, the C# arithmetic operators, because that's what we're going to be looking at here. This is C#. They're mostly the same as what we saw with VBA. The modulus operator, however, is the percent symbol. That's where's modulus? Right there, percent symbol. So instead of mod. One of the most useful operators in the C languages is the and this is missing from VBA, and it's really a shame. It's the increment operator. You can see it here, A++. This operator simply adds 1 to the variable. The opposite is true of the decrement operator, which subtracts 1. This is really useful when you have a variable that's just counting for you. All right, down in the logical operators, we see some other differences. Here, and or are replaced by, see here's or with the two pipes, and then and has the two ampersands. So that's very different. The negation operator in VBA is not. Talked about that before. Here in C#, it's the exclamation point. So you see the exclamation point before the A. The takeaway here is that all computer languages have the same basic operators, with a minor exception here and there. It's just that they look a little different sometimes. The C family of languages tends to use symbols, where VBA and the old Visual Basic 6.0, upon which VBA is based, they use actual words. All right, now for our example. So what we have here is a rudimentary calculator. The way the program works is that the user would click the button and two successive input boxes would appear asking for value 1 and value 2. The program would then calculate the result of applying all these operators to those two numbers. So we'll see addition, subtraction, multiplication, division, as well as exponentiation, raising a number to a power, and taking a root value. Okay, let's look at the code. All right, so we're in the interactive development environment, and we're at the top of Module 1. We're not declaring any public variables or any public constants. We do have a couple of constants, though. They're inside the procedure, inside this program, so they have local scope. Same with these variables, they have local scope. Now, the best part of this example is that you can see how to form proper VBA expressions that will perform operations. That's something you should be looking for through all of my examples. At the top of the module, as I said, I'm declaring variables of type double and variant. So here's the doubles. So we talked about doubles last time. And variant, we haven't talked about that yet. That's a data type that will take anything. As a result, it uses up a tremendous amount of space. But when you just don't know what's going to go into that variable, you have to use variant. So value 1 and value 2 have to be doubles because I want to be able to handle decimal places. So that's why I'm not using integers. The variable vartemp is a variant data type, as I said, and that's our catch-all. I'm also declaring two constants which will be used to provide messaging or titling of the dialog boxes. So notice the syntax on the constants. Here I'm declaring the constants data type and I'm assigning the value all in one statement. I love that. I love having one line to take care of all that. Okay, next the program asks for the user to give us value 1 and value 2. So you'll see that down here with the input box here and here. The program checks that the user entered a numeric value. It also checks to make sure that value 2 is not 0. That would wreak havoc with our divide function. Divide by 0. So all this checking is a must whenever your program is taking in data from the keyboard. You have to assume that the user will enter something ridiculous at some point. So you want to catch it before it causes the program to crash with an unintelligible error message. Finally, the program prints out the results. So that's the last section that I'm scrolling to now. In these first three sections, we're simply putting in the symbol of the operation. We're printing value 1, value 2, and then in this last section, here's where the math is performed. The program is first computing the arithmetic result of the operation, and then it assigns the result to the value property of the appropriate worksheet cell. And it does this using the active cell object, right? So active cell, along with the offset property to identify the coordinates of the cell receiving the value. So here we have offset, and it's offset 0 rows, 3 columns. So the first number is rows, next number is columns. And so so there we go. And here you can see all the math that's being performed. So let's run this and see what we get. So here it's looking for our first number, and let's put in 23. And then our second number, which would be 4. And let's see what we get for an answer. So 23 goes into our value 1 column, 4 goes into value 2, and then here is the result. 27, 19, so that's addition and subtraction. Multiplication gives us 92. 23 divided by 4, 5.75. The raising 23 to the 4th power gives us 279,841. And then taking the, I guess that would be the 4th root of 23 gives us 2 and change. Let's do another one. This time let's do some base 2 math. So the first number will be 2, and let's make the second number 16. And here we go. So 2 plus 16 is 18, 2 minus 16 is minus 14, and we run on down. I wanted this one, 2 raised to the 16th power. We've mentioned that a few times in talking about the size of an integer. Notice it's 65,536. You divide that by 2, you get our 32,767 and change, which is the maximum positive number for an integer. So I think that's pretty cool. Back to the code. So there's our example. I hope you found this informative. Please write comments and subscribe. Thank you very much, and we'll see you next time.